I'm Anil Kumar, and in this video we will learn steps required to sketch transformed reciprocal function. The question here is, explain the steps and sketch the graph of g of x equals to minus 2 divided by x minus 3 plus 1. I've already sketched graph of 1 over x. So we have 1 over x graph already given on this paper. You can actually copy the question, perform the transformations and sketch the graph of g of x. The steps involved here are to identify the key points and then apply the transformations. In a reciprocal function, the key points are, we have two asymptotes. They are very critical. So one of them is this horizontal asymptote. So let me write down horizontal asymptote. Horizontal asymptote. The equation of horizontal asymptote, the x-axis, is y equals to 0. The other key point is the vertical asymptote, right? So the vertical asymptote is the y-axis. And what is the equation of that? X equals to 0. So these are two very critical things to look into whenever you sketch reciprocal function. The other key points are, you will notice that 1 and 1 over x is also 1. So these 2 points, 1, 1 and minus 1, minus 1. Right. So these are very good points to take. And then we normally take these points. So that gives us 6 different points. So here we have 2, reciprocal is half, right? So let me write down these key points also. Let me write down these key points here. So we have, let us say, minus 2. This point is minus 2 minus half. Then we have minus 1 minus 1 and minus half 2. Similarly on this side we have half 2, 1 1 and 2 half. So these are the key points on the function 1 over x. Let me say 1 over x, right? Now let us look into the transformations. In the given function, g of x is equal to minus 2 over x minus 3 plus 1. Now this minus indicates reflection on x-axis. X minus 3. That indicates horizontal translation by 3 units. And then we have 1, which is vertical translation by 1 unit. Now, what we can do is, we can actually perform these transformations on the key points and then write down the corresponding points on g of x. Correct? The transformation here is actually from a general point xy, let's say any general point xy, the x points are going to add 3, so we'll add 3 to the x points. And as far as the y points are concerned, their value will be multiplied by minus 2 and then you add 1. So when you perform this operation on these points, you will get the image points on the function. Connecting these image points, you get the final graph, and that will be your solution, right? So that is one approach. Now what I prefer actually is, I look into reciprocal functions from the point of view of asymptotes. Now we have a horizontal asymptote, y equals to 0, this horizontal line. Now it moves up by 1 unit. So what I will do here is, I will sketch the asymptotes first. So that is what I normally do. And I think it helps. So this is the horizontal asymptote for the final transformed function g of x. Right? Since we have this 1 here, right? So in g of x, the horizontal asymptote is y equals to 1, and the vertical asymptote is x equals to 3. So these are on the transform function. So I'll now sketch the vertical asymptote x equals to 3. Since if I place the value 3 for x, I get something divided by 0, and that is not defined. So 3 is not in the domain of the transformed function we are working with. So that is kind of also a guideline for us, right? Okay. Now, we can actually do these calculations and get our points. Let me do some of them which do not involve fractions. So I'll just do minus 1 minus 1. So if I do minus 1 minus 1, I get 2. And if I do minus 1 here, 2 plus 1 is 3. And on this side, what I get is 4. Substituting 1 here, minus 2 plus 1 will give us minus 1. So basically, I'm looking for image of these points. So image of this point is 2, 3. So 2 and then 3. So that is the image of the point minus 1 minus 1. The image of point 1, 1, this is 4 minus 1, right? So it is 4 minus 1. So that is the image of the other point, correct? So from here you can clearly have an idea that your graph will be kind of like this. Do you get an idea, right? So that is how your graph is going to be. So you are sure that you're on the right path. Now at this stage, let us take a moment to understand. So what you can quickly do to sketch this function? Step number 1, draw the asymptotes. So horizontal asymptote is translation upwards. Vertical asymptote is horizontal translation. Once you get these asymptotes, then find the image points for 1, 1 and minus 1. Do you see? That's very critical for these graphs. Once you do that, more or less, you have a good idea of how to finally sketch the graph. I hope that makes things very clear. Okay, and then you can perform other calculations also and then get few more points. Now I'll get few points using transformation. Now let's go to the transformations once again. If you are listing the transformations for g of x, what do you notice? You notice that since we are graphing here, I'll write down in this coordinate. Okay, that's a good idea. Okay, so the transformations are reflection on x-axis, and then we have vertical stretch by factor of 2, horizontal translation 3 units, right, and vertical translation 1 unit up, right? So you can describe these transformations. I have a very limited space and therefore I'm just squeezing in small areas. So now I will show you how to get a point from these transformations, right? So we already saw that this 1, 1 corresponds to 4 minus 1 here, right? So the next point, which is close to 1, 1, is this point, 2.5. Let us see how to get image of this point. Let's perform the transformations. Reflection on x-axis, that means from here we get to this point, right? So that is a reflection. Vertical stretch by a factor of 2. So half, when you multiply by 2, you get this point, right? And then it says horizontal translation 3 units right. So from here 3 units right is 1, 2, 3, and then 1 unit up, and 1 unit up will lead to that place. Do you see that? So this point which we started with lands up there. You get an idea, right? So that is how it is going to do. And then on this side you can always connect, correct? So this is it. Similarly, you can do for the next point. So 2 when reflected gives you -2. Do you see that? That is reflection. Vertical stretch by a factor of 2, -2 times 2 is -4. Do you get it? And then you move it 3 units right, 1 up. So 1, 2, 3, and 1 up. So that's the point. So basically, this part of the graph you have got, right? So you could sketch like this. So that is the transformation of 1/2. You could perform the same operations and do the next one, but for these ones I will show you the calculation. So with this you will get an idea of adopting different methods to sketch, right? Now -2 plus 3 is 1, and when you multiply -2 times half you get +1, +1, +1 is 2. So the point corresponding to -2 minus half is 1, 2. So 1, 2 is your point corresponding to this one. The next one is -half. So -half plus 3 is 2.5, right? So we'll write 2.5 or 2.5. You can convert to decimals at times. And then we have -2 times y value is 4. So it's -4 plus 1 as -3. So this point will be 2.5 . I'm sorry, the value 2 should have been negative here, right? So at -half it is -2, not +2. So that makes this difference, okay? So this point is -half -2. So when you multiply by -2, you get +4, and +4 plus 1 is +5, right? So that is what I was thinking. So the coordinates are 2.5 and 5. So at 2.5, it is 5. So these are the coordinates. Once you connect them, you get your graphs. So this is your transformed graph. Do you see that? So kind of like this. Well, it's a good idea to find x-intercept. You can place this as 0, and then you'll have 1 plus 2 over 3. So it is slightly more than 1. It makes sense, right? That is your horizontal asymptote. But that is how it is going to look like. So this is the function g of x, correct? So you could plot the transformed function using the transformation from original points to the key points, the image points. You could also plot using graphical method. Following the transformations one by one, you may sketch 2 different graphs, one incorporating horizontal, in this case one incorporating vertical stretch and reflection, the other one translation with horizontal and vertical, right? So that is how you could actually sketch the reciprocal function. I hope you find it informative. You can go through this video once again, see both the steps, which kind of I have mixed them up, so that you can decide yourself which method to adopt. For me, the best method is first sketch the asymptotes, then locate the image of 1, 1 so that you get an idea where your graph lies, and then it is easier to connect and sketch the graph. You also saw in this video that we did make a mistake, and it was very clear that there is a mistake, so we could check and get to the right graph, correct? So once we know where the graph is lying, we know what to expect from the transform point. So that helps. I'm Anil Kumar. You can subscribe and share my videos. Thank you and all the best.